We are starting now this webinar around perfect loads. So my name is Goos Kant, and together with two other persons, that's my colleague Martin Stolp, a business consultant from Germany. Very welcome, Martin. And Jorn Jornsma, functional consultant from Friesland Campina. He will do the customer case, and together we will tell you much more about creating perfect loads. That's the title of this webinar, and hopefully everything will become clear within the next hour. Just a very short introduction about ORTEC. ORTEC is over 40 years old. It's in 13 countries with 1,200 customers and 1,100 employees. And we are strongly growing, and everything what we are doing is using our passion for mathematics to apply that in all kind of optimization solutions which we are implementing worldwide in various industries. And the main industries are in energy, retail, and manufacturing. And manufacturing is the largest one. And I am the global industry director for the manufacturing industry globally. We do that globally. Here you see the map with where our customers are. And today we have about 100 subscriptions from all over the world, from 19 different countries, and also from various sub-industries. And at the right bottom, you see something which is linked to the Paris goals. What we are doing, we want to make an impact for our customers and also make an impact for the world, to make the world a little better. So, and as said, the main area is manufacturing, what we are doing in various sub-industries, and our proposition is in 3 different areas. It's about finished goods logistics. That is, well, the last mile to the customer. That can be a retail DC, that can be a restaurant, that can be another factory. It's about workforce in the warehouses, optimizing the capacity, the shifts to improve efficiency, but also employee engagement. And today it's about order optimization, and that has everything to do with loading optimization. And for finished goods logistics, we had a webinar earlier this year. Here you find the link, and the link will also be in the recordings. Well, we explain the strength of combining routing and loading. And today it's about loading combined with other elements like demand or inventory. So that's what we want to explain. So this is in a series of webinars. We are doing this already, this combination of loading optimization together with other elements in various sub-industries, and all these type of sub-industries have also subscribed today. So we have customers from food products, from beverages, consumer products, other things like cosmetics or cleaning material, automotive, which is also rising, and, well, say all kind of other elements. And we are very happy that it's not, say, our story, but also the story of Friesland Campina, who are joining in this webinar to explain their best practices. So if we think what's going on in the supply chain of the manufacturer, well, there's a lot going on. Of course, not only uncertainty which you can have in demand, but also we had uncertainty in supply over the last couple of years, also due to all kind of demographic instability. Think about the situation in Ukraine, China, etc. There is a shortage in personnel, typically in the Western country, because the amount of people who are retiring is much larger than the people who are entering the market. We have to deal with high inflation, high cost levels. Also, the inventory, because of this uncertainty, has grown in general, but also leads to high inventory cost. So all these kind of things really show that we are living in what we call a VUCA world. It's volatile, it's uncertain, it's complex. So that also has its impact to logistics. So that the loading utilization and the asset utilization is not that high. And next to that, companies have to become more sustainable. One of the targets is to reduce the CO2 emission by 45% in 2030. So that's within 6-7 years from now. So that's, well, quite a challenge. But the good news is that there are also opportunities. If you think about your supply chain, say from inbound, intercompany and customer shipments, then in all these logistic elements, there are questions which you can think of how to improve that. So for the inbound, just as an example, at the bottom, which products to load at which supplier in order that it is in time and efficient for the production. So how can you optimize your, say, MRP process from your suppliers? Or in your intercompany, where you can have, say, demand for inventory replacement, stock transfers. So how can you create optimal shipments satisfying all these demand requests? And from customer shipments, you can think of how can I meet the SLA from my customer? How can I optimize cartons or pallets to meet all this for the customer? So there are various elements where you can think about how can I do and improve that. And the good news is there are a lot of opportunities. So in packing, in loading, in the environment. So if I pick up the loading, there at the bottom, the average capacity utilization in US is only 75%. And in Europe, it's even worse, it's 74%. So the truck is on average almost half empty. And on the left-hand side, there's a lot which you can improve by packing. So a lot of goods are overpacked and there is room. So here you see all kind of elements where you can improve in your supply chain to have a better utilization by a better packing or loading. And it's not only about efficiency, about, say, the bottom line cost, but nowadays it's also about customer satisfaction, damage, SLA. So it is a multi-level goal. It's not a one element, but you have to optimize it over various aspects. And that's, of course, also interesting. How can you do that with all these complex questions? Well, and that's what we are doing with our loading optimization solution. From the top line, you can have stock transfer requisitions. That's what we call. So based on that, with that demand, you can forecast the capacity. And based on all the elements, all the complex elements, you can create the orders and then load and communicate. And Martin will explain that in much more detail. You can also have stock transfer orders or customer orders or delivery orders where you can compute the size. So how can I compute them in such a way that the, say, the loading meters or the pallets are minimized? And how can I combine them to perfect loads? Maybe by splitting orders, by combining orders, by doing some top-ups, everything to create really what we call perfect loads. Or, say, some large manufacturers have with their main customers so-called vendor-managed inventory. So based on the demand and the supply and all kind of priority rules, we directly create perfect loaded orders, perfect loaded shipments, which you can then load and communicate. So this is how it is working in theory, and later we will explain how it is working really in practice. And we have a passion for mathematics, what I explained. And by the way, I'm also a part-time full professor in logistic optimization. So we have a link to academia to use the state-of-the-art engines from AI, machine learning, optimization. And that's what we applied, all these techniques from our company ORTEC, together with latest insight in this so-called RoDev challenge. This is a yearly competition, and last year it was organized together with Group Renault. And this 3D loading challenge consists of a large data set with 200,000 items, 7,000 trucks, and a really big puzzle. The puzzle is mainly about the following. We have, say, fixed route. Here an example from supplier A to B to C to D to the factory of Renault. And you have to pick up goods, and you can distinguish how much to pick up at each supplier, given minimum and maximum, given the demand, such that, of course, the truck is fully loaded, and at the same time, inventory cost is minimized. In that, we have to take all kinds of restrictions, of course, of the loading into account. Well, that's clear. But next to this, there's an important element in what we call axle weight constraints. Not only at the end, but also during the route, during each say transport flow or transport leg. There also all the axle weight constraints have to be satisfied. Let's explain that, say, loading optimization versus inventory optimization. Suppose this is the demand for the coming 4 days. You can, of course, think about, well, every day I load the truck with the demand for that day. This. So then you need 4 trucks, which is quite negative, and you have no inventory. Everything is arriving just in time. So that's, from an inventory perspective, perfect. You can also think of creating really perfect loads. In that way, you only need 2 trucks, but various boxes, various parts are delivered much earlier than needed. Here, 8 boxes in total for 10 days in advance, which requires all kind of inventory and other things. So that's a quite negative one. You can also think of kind of in between. You need 3 trucks and only 2 boxes for 2 days. Say this blue one and this purple one arrives too early. So it's a trade-off between optimizing logistics and optimizing inventory. And that's what we did with our ORTEC team with our optimization power. And here you see our team. That was a diverse team, multiple nationalities, men and women, and we did not, but to be honest, we did not have the first position at the end of 51 teams. We had the third position. The winners were linked to academia. They do every year with the problems they are contributing. So this is a team from pure academia. The second one is a Chinese team linked to Alibaba. So, well, we can also say, well, from the Western companies, we have the highest position. So, and we are very proud of that because we also want to make it into practice and really create a solid solution which we can implement at our customers. So that's what we are doing, and we are doing that, say, as a standalone solution, which is cloud native, but we also do it really in the core of SAP. And we call it our transport load optimization, which is embedded in the processes, in the flows of SAP. Just to give an example of that process. So we get all kind of documents like the stock transfer requisitions or stock sales orders or others, and you can have additional information about the stock or about capabilities or about priorities. That's what we load in our engine together with the, say, the planning object tool. Then we have all kind of load space information. What are we optimizing? Are we optimizing pallets, containers, ocean containers, rail containers, whatever? And then based on all these rules, our optimizer creates a loading that can be based on cartons or on pallets, or say more general on load spaces. As an output, it also can create the corresponding SAP documents, like a shipment, a stock transfer order, or other. So it's really in the process of SAP, and Martin will give a demo around this. So that's, and so as said already, it's completely integrated, so there is no need for interfaces. It's of course certified, and that's also why our customers like P&G or Friesland Campina and many others really like, because it's really in the complete flow of what we are doing. And that of course gives a lot of data which you need from the material, from customers, from vehicle types, all kind of restrictions on packing, characteristics of the material, stackability, axle weight, all kind of general parameters. So there are a lot of things in the SAP environment, in the ECC or in the S/4HANA, which we collect and which we use in all the engine without using any interfaces. And that of course has a lot of value. So significant reduction in the combination of transport and inventory cost. If you have less air in a truck or in a carton or whatever, it also means less damage, which is also an important one. If you increase your asset utilization, that also directly links to an improved sustainability. So overall, a very strong business case. So far, my story, and well, it's very nice to see that we have over 50 people. If you have any questions or remarks or whatever, please put them in the chat and we will come back to this. And if not, then I'd like to hand over to my colleague Martin.
Thanks a lot. Hope you can hear me well. So I would like to tell you a little bit about the story of our journey with Forvia. Forvia is an automotive supplier, the 7th biggest in the world. They have requested exactly what Jose was just mentioning in the RoadNav challenge, a combination between the optimal inventory and the optimal truck utilization. And we built a solution based on TLO. So TLO, the load optimization tool that we just have seen, was the baseline of the solution. And we enhanced it then with the MRP calculation that was built from scratch. So we are not using any standard SAP in this case, but a custom specific solution that we built. So a little bit about the company Forvia. Forvia was founded out of two huge automotive companies called Faurecia in France and Hella in Germany. They are in the meantime the 7th biggest automotive supplier in the world. And out of 2 vehicles which are produced, one is containing components which are manufactured by Forvia. So it's really a large company. They are running 400 plants all over the world, and of course they also have a huge inventory. So the main goal of the project was to be able to reduce, on one hand, the transportation costs by trying to optimize the truck utilization, and on the other hand, and that seems to be even the bigger impact, to reduce the inventory so that they can save interests for the inventory they need to keep. What we built as a tool is the so-called integrated supplier optimization, ISO. The name was given by Forvia. And in fact, they were looking for some load optimization tool like we can offer with TLO embedded into SAP. But it took us quite a while to understand that, in fact, they are looking for a new MRP tool which is integrated with a load optimization tool. And this MRP tool has been built from scratch based on the requirements of the automotive industry, using SAP raw data as an input, and calculating then based on the raw data that we receive, like production plan, the actual stock situation, and that is in real time in the moment of the calculation, the supplier backlog, so what they are still going to receive from a supplier which is in transit, plus the potential production backlog, so items they would have, they would need to produce in the past, but there were no, due to restrictions, they were not able to do so. And of course, the reordering point, or called safety stock. The goal of this whole calculation was, if possible, to reach at the end of the day almost the safety stock, so to avoid that we have unnecessary stock in the warehouse. And in addition, there is some input which is based on the truck schedule. For a lot of their trucks, they have the so-called fixed route agreements. That means that they have a real schedule with their supply, with a third-party logistics provider. So 3 times a week or 5 times a week, they will receive a truck, and they have to plan accordingly. The only freedom that they have in that process is that they are able to skip a truck in between in case it's not needed. And then, of course, it's going more and more in the direction of flexible agreements, so where Forvia can really order the truck based on their demand. Yeah, and this the goal, as mentioned, of this this whole application is, of course, to have a more dynamic way of calculating the demands, of optimizing the stock and the inventory, and on the other hand, to reduce the transportation costs by better utilization of the truck. So we build handling units on lot sizes that fit on one hand to the demand of the production plan, on the other hand are using the truck space as much as possible. There's one thing that we are able to do, and that is to split demands of a day. So like Jose showed before in his slide with the small trucks, where you could see that one box was moved ahead and the other box was then delivered on the day of the demand. There are quite a huge number of restrictions that we have to consider. On one hand, the standard loading restrictions, most of them we have already seen in the presentation of Jose. So, of course, there are specific truck types that are either provided by the carrier or that are required to optimize the load. We have, of course, some stackability and compatibility restrictions. So not every product can be loaded with another product in the same truck. Not every product can be stacked on top of another product. All this needs to be considered in the load optimization engine. We have the situation that Jose also showed already, that we have multiple pickups. Even one supplier can have multiple loading locations. Or on the opposite side, we have multiple plants to be delivered or multiple unloading points in a plant. All that needs to be considered during the load optimization, because of course you need to keep together what needs to be loaded at the same location in the truck. And if possible, you also try to keep together on the truck what needs to be unloaded at the same unloading location. We are using as a baseline the standard SAP packing instructions with sub instructions. So normally we have items per box. They are using mostly standardized plastic boxes for carrying the items. And then there is a defined number of boxes which is placed on a pallet. And then we have a lot of specific restrictions which are coming from automotive industry or from the agreements with the suppliers. So they are able to define a maximum number of days that they want to pull ahead items. The functionality behind is even considering the volume of the goods. So and the price per cubic meter or per cubic decimeter. So we are trying, if we are filling up a truck, to use the cheapest item in regards of the volume, which helps a lot to save costs for the inventory. If they receive multiple trucks a day, you can imagine then they want, of course, to have all goods in every truck instead of getting one good in the first truck, the whole quantity for the day, missing eventually other items that they might need in the production already before the next truck arrives. So we are trying to have of every SKU the same number of items on a truck. They have agreements with the supplier until how many days in advance they need to freeze the demand. So they are ordering 2, 3, 5 days ahead. That depends, of course, on the distance between the supplier and the plant and on the agreement with the supplier. And of course, another very hard constraint is the minimum lot size and the rounding factor. Normally, a rounding factor could be either a full box, full layer of a product, or a full pallet. And the minimum lot size needs to be considered, even in case we have multiple trucks. We have at least to order one time the minimum lot size at the supplier per truck. And one thing which comes on top is then the empty management. So partially they are trying to combine the outbound and inbound process. So when they order goods from the carrier and they know that they have a certain stock of empties available, then they send with the same truck first the empties back, and then they collect the incoming goods for the production. Yeah, and the goal of the whole functionality is to decrease costs as much as possible. So order the lowest possible quantity that fits to the demand. As mentioned, the goal is to reach every evening almost the safety stock or the safety stock, but never decrease that, of course. And on the other hand, they try to use and plan the trucks according to these demands and utilize the trucks completely. And yeah, what I've prepared is a small demo to show in the system how that works and how this whole calculation is done. And you will see it's even there's a complex, really complex calculation behind. It's a rather fast process. Maybe one more slide which shows a little bit all the input that we are using for the calculation, and to get then the output of what needs to be ordered by the per supplier on SKU level. So let me quickly share my screen. That works now. In a second. So the customer was so friendly to allow us to show the example in one of their test systems. So this is now the Forvia system where we are doing the demo in. You can see that we have here TLO, so our transport load optimizer. I open the optimizer. We have a so-called defined planning scenario, which has a lot of parameters behind, which are used to steer the algorithm as one example. We select the route that we want to calculate. Then there are some given parameters already maintained on route level. So in this case, we are going to calculate either 4 weeks time horizon or a maximum of 6 trucks. And we have to define which kind of truck we are going to use. I will use the Jumbo truck. and we want to utilize it for 100%. The reason why we have this limitation here, this potential limitation, is that they are currently not sending over the information about how to load the truck to the supplier. And if we utilize it fully, then there is a huge risk, of course, that they do not get all the stuff on the truck. So then I will run the application. The first thing we are doing is that we are in the background receiving, you can see here, we are receiving all the SAP parameters which are required for the calculation. Then we start already with the MRP calculation. This will now update all the demands based on the input that we received, like the production plan, the actual stock situation, the supplier backlogs, production backlogs, etc. And what you can see now here on the screen is the list of the items with the requirement date. And here we have the information about the baseline which has been used for the calculation. So for this material, we have an actual stock of 869. That's the real-time stock in this moment, or in the moment when we started the calculation. We have a safety stock of 376 items. So we should never end on a day with less quantities than these 376. We have to produce still about 7,000 items, which we are in delay. On the other hand, we can see that this was caused by the supplier who wasn't able to deliver 7,000 items, which we are missing. The production plan for that day is 338 items, and that is the expected consumption for that day, which is in fact the requirement backlog. And out of that, we are calculating then what is the projected stock at the end of the day. And as you can see, on the second day, we have a risk for shortage. But as we are already in the frozen zone, we are not allowed to order anything on top. So this would be now the typical situation where they will have to order an emergency transport. So what they missed to order here was the production amount for the previous day. So as you can see, at the end of the day, they expect to have only 47 items left. Our calculation starts on the first day after the frozen zone. So we are now calculating the demand per day based on the production plan and on the reordering point and the projected stock that we expect at the end of the day. We assign priorities by the requirement date. So the first requirement date will get the highest priority. This is done for all materials to ensure that the full demand of the first day will be considered on the first truck or trucks. And yeah, what we do then as a next step, I mean, this is really just for justification by the planner so that he can see how the calculation has been done, is that we hit that button here for the tour proposals, which is, by the way, a standard TLO button. Just with some additional functionality behind. And what we are doing now, and that is different to the regular TLO calculation, is we are calculating the trucks in iterations. So with every truck that we plan, we do again an update of the whole MRP calculation, because with what we have planned to be received, of course, our stock is changing, and so our projected stock at the evening is changing as well. And now the system is in the background calculating either this 4-week horizon or the 6 trucks, as we have seen, or if we have not enough demands until the final horizon, it will stop after it has planned all the items which are marked for planning here. This is the checkbox. There's one thing, one technical restriction. Unfortunately, we are not able to show the graphic directly here in the system because of some security settings on the customer server. But to be able to show something, I have taken a screenshot up front. So from the first truck that you see, this is the load graphic to the truck. So as you can see, it's pretty full, and we even placed here some partial pallet quantity on top of a pallet to utilize the truck as much as possible. And on the other hand, not to pull too many items ahead. So trying to take care on the inventory level on one hand and utilize the truck as much as possible. And what we can see in the result itself is that when you click here on the documents, then you will see which delivery dates are on the first truck, and we can see that we have up to the 2nd of October. Sorry, that's already now again. You can see that we have on the first truck items for the 25th, so the priority one, which is the first one that needs to arrive until the 27th. So we are pulling 2 days ahead. In fact, all that we would need on that day is the first item with a quantity of 680 pieces. But as they need to be there on the 25th, we have no other choice than to order a truck on that day. And of course, then we are trying to fill up the truck with items with a lower priority, which you can see here with the items which are ordered for the 26th and 27th. And that is then the same, of course, for all the following trucks as well. And at the end, they are going to release these trucks. The release of trucks creates in the background an inbound delivery, which is sent via EDI to the supplier. And at the same time, they are also ordering via EDI the trucks which have been calculated so that the carrier knows how many trucks on which day he needs to provide. That was so far what I wanted to show. If you have questions, feel free. Otherwise, I will hand back to Roos.
Thank you, Martin, for both the explanation of the business and the demo with all the details. And here you see, of course, this is really an innovation compared to the more standard load building. It's focused here on automotive and on supplier, but you can think of, well, this can be applied in other industries, not only for, well, here for supplies, but maybe also for intercompany, where you can have all kind of requirements for production or replenishment, and similar towards your customers, where you can have VMI or other flexibilities to optimize your loading. So I think this is a very nice concept, which is, well, applicable to multiple industries and multiple parts of your thing. So thanks, Martin, again. And if
maybe one comment to your what you just said. It's a standard application, so we built that all in a separate namespace in SAP. It can be delivered to any other customer. All that we need is of course then the input data from the SAP system, like material master packing instructions and the MRP data. Yeah,
thank you. And to show the richness of this, say, TLO, the transport load optimization, I like to give the word to Jorn Jansma from Friesland Campina, so from the dairy industry, for intercompany and outbound deliveries. Well, totally different sub-industry, different part of the supply chain, but the same challenges around loading optimization. Jorn, are you ready to share your screen?
Yep. Can you see my screen?
Yeah, I can see your screen and hear you. Yep.
Let's start at the beginning. So I'm going to briefly talk about the load building optimizer that we are using from ORTEC. A little bit of an introduction with the people from whom we used in the project team to deliver this. I was thinking maybe they would join this call, but they're not joining. So we had someone from the business, of course, involved in all the projects that we did, and also someone high up from IT management. A little bit about Friesland Campina IT. Friesland Campina, we are of course a dairy company. We are a dairy corporation, and we are vertically, let's say, integrated. So we are doing everything from grass to glass in the entire supply chain. We are active. And we have a very wide range of products that we put in the market in order to valorize let's say the member farmers' milk that we process. A little bit about the company, some numbers about our revenue. We're active in 31 countries. In terms of facilities, we export to over 100 countries. We have more than 20,000 employees. And we deliver dairy to millions of consumers every day, for example, directly actually and indirectly. So we also are very active in ingredients. That means, for example, for infant formula, almost every infant formula product, the finished product that you can find in the market, has ingredients that are being produced by Friesland Campina. This is a little bit our where we are mostly operating in Europe, where we have strong local brands. Also in Asia, we are very active with infant formula. And we're trying also to expand our foothold in Africa and the Americas. Yeah. So why did we choose to let's say use a tool to optimize our loads? Basically, one of the most important aspects from IT side was actually that we had a lot of custom built functionality from even that were copied from legacy systems into ECC that we were still running, which were becoming very hard to maintain, which were not documented, which were not scalable, which were also not accurate enough, and were lacking a lot of functionalities. And the result of that is actually that our business was paying too much or was ordering too much transportation, let's say, capacity, and thereby paying more than that was actually required. And of course, whatever legacy functionality you have in your system is by default, it's not future proof, especially when you plan to migrate also to S/4HANA. And also, we have only a handful of people that understood our complex solutions that we created in-house. So we did a tender. We did it with ORTEC. We did it with some competitors. We had a business case. And we went through all the steps that you normally do to do a tender. And in the end, we decided to go for ORTEC. Whom were actually the most mature in their solution, and hence we decided to start a journey with them. During the maybe some touch points on this. What's important from IT point of view, and what's important from the business point of view. Of course, you want the lowest cost. You want to fit with your architecture. It should be easy to integrate and to maintain. And some key points for the business is that it should deliver value without impacting your current business processes. So a bit about what we have done already so far with ORTEC is we have already brought live a lot of sites with the delivery load optimizer, mainly in Europe, and that was quite successful. We had quite a good reduction on transportation costs. And mainly we did this for the food and beverage, let's say for the consumer market, and for the trade, let's say for the commodity market that we have. And we had different businesses with different goals that they wanted to achieve with the load optimizer. When you talk about consumer products, it's sometimes more, you have a fixed demand that you want to deliver, and you want to know what is the transportation capacity that you need to reserve. And when it comes to intercompany transports, the main goal is always that you have your trucks as full as possible. We had different scenarios that we were able to cover with the load optimizer, and we are still delivering. We are still rolling out this delivery optimizer to new sites. And then the next big step was actually the sales order optimizer that we have already live since June, indeed. 2022, so already more than a year and a half. And the sales order optimizer has a bit of a different goal than the load optimizer, which is maybe not so much about transportation cost, but about OTIF, so on time in full. That means that when a customer places an order at FrieslandCampina and not knowingly places an order for a full truck plus maybe 2 or 3 boxes, you want to be able to intervene in that order and reduce it to just a full truck and remove those 2 boxes before you create the delivery, because then you fix already the quantities. When the delivery is already created or sent to the warehouse, then you are too late, and of course that those 2 boxes will not be delivered. And that means that you have an impact on your OTIF score, and that is something that we wanted to, where we had a very good business case to deploy the sales order optimizer for. So that's also live, and that's also quite successful. We have built in some add-ons to make sure that the order automatically falls into a block whenever we exceed certain threshold in terms of number of trucks that should be ordered by a customer. What is also already live is the stock transfer requisition. That we brought live because for the intercompany flows, one of the challenges is that indeed also when you already have the STO or even the delivery, and you're starting to, let's say, remove shipments or deliveries, and not deliver certain deliveries because they are only 1 box. Those quantities and those dates, they are already in the system, and they're kind of fixed. So that requires a lot of work to remove it and to clean up the system after you do an optimization on the delivery level. And that's why we decided also that the stock transfer requisition was actually the best solution to also do the internal transport. And that's also live, and that's also a big step forward also in terms of process maturity. The location that went live with this had a couple of people who were just with Excels calculating their truckloads 3 times a week for 2 hours at a day. So that was taking actually quite some time in their daily routine. And by this we allow them to focus on more important things. And the next, let's say that in the current phase, we are looking at bringing live new locations with the template that we have already built. So we want to use more of what we already have instead of for every location build something new. We are trying to bring live some locations where they use loose loading, and we're also looking at locations where we have ocean scenarios, which would be a first time that we use the optimizer for, let's say, for container flows, which is slightly different than from the truck flows. Maybe some evaluation and lessons learned. It's out of the box, so there's also in the presentation it's mentioned that ORTEC is integrated in SAP. If you use standard SAP, that's no problem. If you have built your own customizations, then you can have some problems, of course, but that is, of course, with any other add-on that you start using. So we had to do quite some rewiring of, let's say, of the integration points. For example, we don't use the standard SAP packing instructions like the POP and the POF. We don't use that. We have our own customization for that, and we had to do quite some work both on FrieslandCampina side and on ORTEC side to make sure that this is working. We have a lot of non-standard scenarios, both in terms of picking and RTIs, which we also needed ORTEC to facilitate. So we had to do some developments in order to make sure that some very dairy industry specific RTIs are actually we are actually able to use those with the load optimizer. And the ease of, let's say, of implementation. I think this was also already touched upon a little bit in the previous presentations, is that the load optimizer is a mathematic solution, so it will always try to get really the most optimized truck that it can calculate. But sometimes, even though when you calculate it, when you review it, the result from ORTEC, it's too tight sometimes. It should fit. But in the warehouse, you see that maybe some big bags, they lean to the left, or we have some overhang sometimes, or there are other practical considerations that prevent you from actually reaching that optimized, that really 100% optimized load. And that's something that was an important lesson, is that you really do visit the factories or the distribution centers, to make sure that you have an idea. Okay, how does your pallet build look like? How do you load? What are some issues that you encounter? Master data. A lot of cleansing we had to do. Some locations were not very. We're, let's say, behind in master data maintenance. So at the same time, that's a good exercise to make sure that your master data is correct, and especially the dimensions and the weights, and also the number of layers per pallet. In some cases, that was still missing. So that was also some lessons learned in our journey with ORTEC. Maybe some numbers. We achieved a 3% truck fill increase for the locations that went live, 10% productivity increase. Also in the warehouses, we had an increase in productivity because we were able to make sure that the load optimizer always puts the pick quantities together in one truck. So if you have multiple trucks ordered by one customer, and you have pick quantities spread across those trucks, that means that you have more picking activity also in your warehouse, because you have more partial pallets, instead of maybe one go through the warehouse with one very big partial pallets. You have multiple smaller partial pallets because you have to spread them across the trucks. That was one of the very interesting points that we were able to solve also with load optimizer. Indeed, what I also mentioned earlier is that we have already identified new locations where people are. Especially in Asia, we have some locations where there are a lot of people just all day long with Excel calculating orders, calculating how many containers we need for those orders. So that's still a lot of potential to make sure that we really standardize and our processes into a more mature way of working. Yeah, that was it. Maybe are there any questions?
First of all, thank you, Jorn, for your very clear and openness presentation. Very nice. I think you can, indeed, and so that we have some time now to debate. And also you explained well for intercompany sales orders globally, containers, so it's really a broad solution. I was wondering, the previous one, Martin explained about inventory. Is inventory cost and inventory also a topic you want to address with the load optimization?
Not specifically with load optimization, but it is a topic actually in Friesland Campina. So inventory costs. So I think it was a very interesting presentation earlier. So we will definitely have a look at it. But it's not something that we are addressing at this moment with the tooling of ORTEC.
Okay. From the audience, are there other people who have questions, remarks?
Roos, there's one question in the Q&A from Pat Murray. Can you see it?
Yeah. I have a scenario where we deliver bulk feed to customers. Typically, customer orders between 4 to 6 tons each time. We group the orders into multi-compartment trays. My question is, what options are there to deal with order size adjustments in order to maximize load fill? And our customers allow a degree of flexibility. So if we have 5 times 6 tons, and the truck has 28 tons, we would reduce to so that you have that one. So that's not necessarily in this solution where we have packed goods, but it's more in bulk goods. So that's a little bit different topic compared to the packed goods, but it indeed has to do with inventory optimization. And my answer to Pat will be a little bit like what Martin Stolp explained, is that you have a kind of minimum size which has the highest priority. For example, what has to be delivered tomorrow, and then you have some top-ups which has a lower priority which can be added if you have sufficient capacity left. And maybe that's, by the way, similarly what you're doing, Jorn, with the stock transfer. You first what needs to be done and then add what can be transshipped. I think, I think I will pick it up separately with Pat, but that's the way I would model it, with priorities in what has to be delivered and what can be delivered, and in that way build up your loads as good as possible. And this is, by the way, then for bulk feed compared to the packed scenarios which we are discussing today. Good question, Pat.
You can also use your microphone if you want.
Yep.
Yeah, maybe some additional information to that topic. There's also the option, of course, to split deliveries or split orders in case they are not fitting on a truck. So you can run the truck optimization so that it fulfills the truck to the maximum, and what does not fit on the truck can be split off even in SAP, and that is triggering then also the standard SAP order split or delivery split.
Yeah, that's also what you can deal with, also with mega orders, I think, Martin. Yep.
Yeah.
So we actually do the same. So we have, for example, for our internal flows for the SDRs, we have a certain planning horizon, and you just look at the SDRs which are open, and you say, okay, plan this quantity, and then of course maybe the last truck will only have a very low utilization rate, and you can set thresholds for that, meaning that if the utilization rate is below a certain level, you will not release, let's say, that tour, and then that quantity just goes back to your open SDR, and then it will be picked up in the next run. So that's how you could deal with that.
Yeah.
And with
Nice.
I think we do, and the same for we have actually exactly the same for our orders. Let's say for our sales orders, where we just hold the order, and then we see, okay, we have the next truck is only 2, let's say, containers or bulk containers inside the truck. We would just remove it from because we know there's a certain level of flexibility. We remove it from the order, and the order goes out of block, and then you can continue.
Thanks. Nice explanation, Jorn, to give, well, how the process is running. Given the time, if there is no further questions, then I really would like to thank Jorn for your presentation and your time and support. Really, very appreciated. And Martin, for all the details of the innovation we are doing together with Forvia. And I want to thank you all for your presence, and the recordings, the presentations, and some key insights will follow shortly. For those in US, have a good day, and also for those in Europe, have a good evening. Thank you all, and bye-bye.